actually the words mean something. So if you look at the text, the words are meaning something. If you look at the text, one word and other word in the same context are saying something interesting. So for instance, it's very likely that if you analyze the text, for instance in the domain of computers, the words PC or notebook is going to appear more frequently with keyboard, with mouse. So there are some semantic connection there. So what the method does is try to track that kind of information at the lexical level, because the rest of the information is contained in this kind of rule. I'm going to show you an example of the rule. And then once we got that information, we have this kind of data. With this data, what the method does is to try to provide hypotheses. If you look at the previous method, known as the Swanson method, none of the methods try to hypothesize. What they do, they try to analyze every document separately. So what we do here is to try to hypothesis. And the idea is to have an algorithm, in this case an evolutionary computation algorithm, which is actually to look at this initial hypothesis and is able to cross between each other in order to come up with something completely new. That's the first thing. And the second thing, that, as I said before, is that we are actually capable of getting a lot of patterns, a lot of hypotheses, but the second problem is that I cannot deal with all these patterns, so I need a way to filter this pattern. So the second contribution of this model is to try to provide metrics. Actually, you remember the metrics, the first ones, like support confidence, are a sort of metrics in order to assess the novelty or relevance of a pattern. So what we did here is to try to provide several criteria, several metrics, in order to automatically assess the quality of the pattern. So for instance, of the research and so on, and finally, in this part, the author is referring to the conclusion. That's just from one text. I'm not saying anything new at all. I'm just trying to represent. Once I got this information, I convert this information into a rule-like form. A rule-like form looks like this. It's trying to express exactly, but in a very understandable way, what the text is saying. So this kind of rule is the kind of rule that I generate here. So what I do next is try to provide to the algorithm all my set of rules. And then I asked it to come up with a new combination which actually involved novel knowledge, which it actually, in addition, had to be coherent, had to make some sense, because we are dealing with natural language, and has to be novel in some way, right? So I'm not going into detail, but the good thing with this approach is that this approach defines six criteria. 6 criteria means 6 evaluation metrics. That means that every time that the method generates a new pattern, each pattern is assessed by 6 criteria. So I'm not going to explain how to deal with this because it's a multi-objective optimization problem. But actually, if you have the 6 criteria and you have a score for one criteria, for each criteria, for each pattern you are going to have a vector of quality. But the problem is that how you compare two vectors in order to establish whether one is better than the other one or the way around. It's not an easy way to do it. If you got 2 single numbers, it's very easy. All right, this guy is more interesting than this guy. Yeah, but in a multi-objective world, it's a bit more complicated, right? But this is the kind of, actually this is the actual pattern generated by the system. I don't expect that you understand because I didn't understand the pattern at first. So what I had to do is to call for an expert on agriculture in order to interpret the data. So he was able to analyze this. Actually, this is not the thing that is generated by the system, but the thing that we manipulate in order for the expert to understand, because the system just generates rules. But if you are an expert on agriculture, you don't have to understand my rule, you have to understand text. So we add a step in order to convert this very weird rule into natural language, back to natural language, right? And the result was very interesting, right? Because what we did is we run the system. We pick the first or the best 25 hypotheses or pattern generated by the model. We have actually the score of each pattern. Actually, this is a lie. we were talking about multi-objective metrics, and actually you see a single number. This is a trait here. So we convert all this information in a single number, just in order to compare with human performance. So what we did is to include the 25 best hypotheses or best pattern generated by the system, and we compare the evaluation between the system, which is the dotted, the evaluation given by the system to the pattern. I remember that the system tried to establish how novel or how interesting the pattern is, and the evaluation given by the actor. Here, well, actually, it's not a very good graphic, but if you scale up, you will see that most of the time, it seems plausible to think that most of the time, when the humans say that one pattern was a very bad pattern, it was not interesting, the system says exactly the same. Yeah. So, for instance, here we have a drop here for this hypothesis number 3, right? For pattern number 3, the helper said that it was very bad. Actually, there's nothing new with that hypothesis, and the system says something similar if you scale up. So it's very interesting. Actually, correlation was better than for a mini approach. Actually, it was around. Went very well, about 0.485 out something, right? So, so I think I'm going to finish here for the time's sake. I was going to talk about all the time, but I think that I already have talked about too many things for you. Just my idea was give you a general overview of the field, the different ways how you can deal with your whole field, with your own field of interest by applying text mining techniques. Let me go faster. Don't worry. Don't try to read this. There's too much mathematics. So as you can see, text mining is a very emergent field. Text mining in a very good sense. As I said at the beginning, many people explain doing text mining, but actually it's information extraction, as I said before, is far from text mining. You need some more complex cognitive tasks in order to deal with this kind of pattern. Obviously, NLP technique, standard NLP techniques are very useful and can be directly applied to do this kind of thing. But actually, as I said at the beginning, NLP was not the obvious choice at the beginning. Actually, most of the people doing with this kind of techniques are called association rules. It's not doing NLP actually. They just happy with keywords, and then they just do some analysis based on keyword, based on term, right? Obviously, and the other thing that I wanted to show you. After finishing this presentation, that obviously we already said at the beginning that the web, the internet has a lot of potential to apply text mining technique. We have a bunch of text. We have a lot of need. The people need to deal with text in different ways. Actually, I don't know if you have noted, but some of the search engine, I don't remember the case of Google, but probably AltaVista, provide facilities to do some kind of text mining analysis. For instance, this system provides kind of what they call directories. So directory is a kind of clustering. So you have you have directory for, I don't know, entertainment or sport, fun, and every time that you click on this topic, so you see all the related documents to this topic, and this directory facility is updated automatically, right? So they already know what the topic is, but they don't have any idea what document should be in this topic, and that's the way how this technique works. So